Stanford University.
Okay, welcome to lecture number 4 of Stanford CS193P, Developing Applications for iOS. Today we're going to finish up what we started on Tuesday with Foundation, talk a little bit about the collection classes and how to enumerate them and what we mean by the term property list, which is related to that, and also a little about user defaults, which is also related to property lists. And once we finish up all that foundation stuff, we're actually going to go back to talking about the language, although not really about the language, but about how we use the language. Specifically, how do we create objects? Those 3 classes especially. The 4th collection class is NSSet, which sometimes is the weak stepsister of the other ones, but it turns out set is a pretty valuable way to represent a bunch of objects as well. A set is an unordered collection of objects, and all the objects have to be unique, so you can't have any duplicates. An array could have the same objects in it 100 times, right, at each index. But a set, all the objects have to be unique, and it's not ordered, so you can never say object at index. Okay, so it's immutable. Its important methods count, as usual, how many are in this set. And really important method is contains object. Okay, returns a Boolean whether this set contains this object. You can imagine using set. You learned in computer science, I'm sure, set theory and things like that. You can imagine using NSSet for some of the problems you would solve using set theory. It also has a cool method called anyObject. It'll just return any random object out of the thing. And we'll show you why that is cool. It also returns nil if there's no objects in there, but it's also very valuable for some other things. You have a question back there?
Do the other foundation classes have contains object also?
Probably array does. The question is, do the other classes besides set have this method contains object? I'm sure they probably do. I don't remember offhand which ones do, but I think array probably has that. Question?
I was just wondering if you could explain the logic behind putting in immutable versions as well as mutable versions.
Yeah, so the question is, why do we make such a big deal here about we have the immutable versions of all these things, and then we have the immutable ones, and then we have the mutable ones? The main answer to that question is memory management. And we're going to talk about that later today. If you have an immutable thing, its memory doesn't have to be owned, somebody's managing that memory. You can pass these immutable ones, the read-only ones, you can pass them around and they kind of ephemerally come and go as people need them. We've been using all immutable strings, for example, when we did the display.text, set a string by a pending string. Those are all immutable strings. We haven't used any mutable strings as yet, for example. And in the demo today I will do a mutable thing, just so you can see what that looks like. But the answer to your question is memory management. That's why we do that. Question?
Does contains object compare 2 pointers, or can it is there a comparison function that compares 2 objects?
Yes. Right, so the question does contains object mean this object pointer is in the set, or does it mean there's an object equal to this object, is equal in a semantic sense to it? And let me go down here and I'll talk to you about a couple other methods. Just make objects perform. Here's a method that does the is equal. Okay, member. So member does is equal on the object to find out if it's in there and returns the object that it found that matched. Okay, whereas contains object is telling you this object itself, this instance is in their set. Okay, and those are 2 different things, subtle difference, but important. Mutable set. Mutable version has add object and remove object. And it also has 3 kind of cool union, minus, and intersect set, where you can take 2 sets and say union them and get a new set. You have a mutable set, you union it with another set and you'll get a larger set, right? So that's one of the things that you might want to do with a mutable set that you wouldn't do with a regular set. Mutable sets, medium commonness, because a lot of times you're creating them, you're collecting some classes, and we're going to use a mutable set, hopefully if we have time, in the demo today. You'll see why we do that. All right, so enumeration. So you've got these dictionaries, arrays, sets, and now you want to enumerate through all the items in there, either all the keys or all the values in a dictionary or all the values in an array or a set. How do you do that? And there's language support for this, I believe similar to what's in Java, if I can remember. I can never remember which languages have which things, but I think Java has this one. It's basically for in, all right? And it looks like this. So if I wanted to enumerate through all the objects in an array, I would say my array, nsarray star my array equals something. So I have an array that I got from somewhere. I made it myself or somebody gave it to me. And then I just say for variable typed. So ns string star string. Now I could type string outside of the loop, but usually we do it right here in line. For variable in my array. And then inside the curly braces, the variable string in this case will have the next item in the array. So it's just a for loop where it's iterating through, enumerating through actually each of the items in the array. So every time through there, this is going to ask the next object in the array, what's your double value, for example. Okay, make sense? Question?
What if all the types inside the NS array are not all strings?
Yeah, so the question is, what if my array has mixed objects, not all NS strings? And I'm going to show you that right now. It's like a shill in the audience for me. So what if you had a set, let's say, or it could be an array or whatever, but I'm just going to say a set to show you something different, where in the set is different kinds of objects. Might be strings, could be numbers, could be other kind of things. So how would that work? Well, we would just do for, when we do our for, we'll do for ID obj. Okay, instead of ns string star string, I'm going to do ID obj in my set. And then inside the curly braces, I'm going to be careful what I do in there. Okay, because obj is ID, pointer to any kind of object. I'm extremely likely to want to do some introspection there. Ask it what kind of class it is, and then maybe send it that kind of message. Or if it's another kind of class, send it a different message. This code make sense? We're going to do that today as well in demo. Looping through the keys or values of a dictionary, exactly the same. So here I have a dictionary whose keys could be any kind of object. And so I say for ID key in my dictionary. The for in for dictionaries goes through the keys, not the values. And if you want the values, you would just send object for key to the dictionary inside the loop, and you get the values, right? You look up the hash table. Notice here that key is not an NS string star, it's just an ID, but I don't need to do any introspection to do object for key on it. Okay, NS dictionary, you can pass any object to object for key. If there's no hash in there, if it doesn't hash well, or it hashes but it doesn't equal the thing once it's hashed, then you're just going to get nil. All right, because there's going to be no object for that key. All right, so that's enumeration for in. You're definitely going to be doing that. All right, so property list. So the term property list, we just define it when we're working in iOS. And all it really means is any collection at any depth of these 6 classes. NS array, NS dictionary, NS number, NS string, NS date, and NS data. Okay, which are all classes we've talked about in the last 2 lectures. And they could be subclasses of them. They could be mutable versions of them as well. But if you build any structure out of these, then we call that a property list. So for example, an array would be a property list if all the members in the array were also property lists. So if they were all strings, or if they were all arrays of something that is also a property list, then that would be you'd be able to call that array a property list. Or for a dictionary, all the keys and all the values must all be property list. Okay? So I use an example here, an array of dictionaries whose keys are strings and values are NS numbers, that would be a property list, because all the keys and values and all the values of the arrays, everything is all one of those 6 classes. Why do we define this term property list? Why do we even say this? Because there's some API throughout the SDK that can operate on property lists. Okay, it's a method that will say something like this one, write to file. You specify a path. The variable I have there in the square bracket is plist, so that's the thing I'm sending it to. That could be an NS array, NS dictionary implements this method, but the bottom line is the thing you send it to has to be a property list, so it can't be an array with other things in there besides the 6 magic foundation classes, or this method will not work. Okay? And you'll see some property lists. Your first homework is going to require you to implement some API that takes and receives property lists as well. And that's mostly, I put that in there so that you, A, understand the concept property list, and B, so you understand how to work with dictionaries and arrays, because that's really one of the main focus points of today's homework, is how to work with all this stuff. All right, one other miscellaneous foundation thing I want to throw in here, because it's very related to property lists, so this is really appropriate time to throw it in here, is NS user defaults. So NS user defaults is lightweight storage of property lists. Okay, and that storage persists between launches of your application. So it's like preferences, right? Things that your user, you want to store about what your user is doing, that the next time they launch, you want to have that information available. However, it's not a SQL database, okay? It's basically it's for small things, arrays of strings, maybe dictionary with arrays as the values, but then the arrays have strings again. You know, small stuff. It's really for user preferences, basically, or for maybe storing the way the user interface is currently laid out, so when they come back, it's that way again. Things like that. You read and write from NS user defaults using this shared instance called standard user defaults. You can see I'm sending this class method, standard user defaults, to the class NS user defaults. I'm getting the shared instance. Okay, it's shared. Every time you call this, you get the same instance. And then you can send it different messages. Like this one is set array for key. And so RV array right there would have to be an NS array. Now, the items in the NS array can be any property list items. So it'll keep going down and down, following inside of the collections. And then the for key is just how the string you're going to use to look it back up when you read it back in. So what do some of the methods look like? You can set all primitives, so there's like set double, set int, set bool. You can get them back, so integer for key. Notice integer for key returns NS integer instead of int. NS integer is just a type def that makes it so depending on what platform you're on, you get a 32-bit int or a 64-bit int if you're on a 64-bit machine. You can treat it as the same as if it were an int. It's a primitive. It's a type def to a primitive type. And then set object for key, that works as long as obj is a property list. It can be any property list. Array for key is a little different than just getting an object for key, because if that object that's in the user defaults for that key is not an array, this will return nil. So that's a subtle difference than just saying object for key. Yeah?
Can NS user defaults be shared between applications?
No. The question is, can NS user defaults be shared between applications? And the answer is absolutely not. Okay, one thing you're going to learn when you run your application is there's very strict boundaries between applications. There's a sandbox that you get to play in that you can't see other application sandboxes for obvious reasons. Okay. One thing you always have to remember with NS user default is after you've made a batch of changes, you know, set double for key, you want to say standard user defaults synchronize. Synchronize basically writes it out to disk. You can think of it that way. It also would read it in, although on the iPhone, when you're doing iOS program, you really don't have to worry about that. As soon as you start asking for keys, it's going to read it in. Okay, but every time you do it, and you could do it after every single change or like after a little group. If you're going to change 5 things at once, change all 5 and then synchronize. Okay? All right, so that's it from Foundation. So this next stretch of topics is all about allocating and initializing objects and then how we manage the memory of them. This can seem, the first time you see it, like, oh my gosh, all these rules, how am I ever going to keep up with all this memory and these objects? But you're going to find that when you start programming, there's actually very little to do. Because of the way that this is all structured, most objects, you're getting them, ownership is obvious, and you don't even have to explicitly go into the memory management of it. And so we'll see why that works. But we'll start with creating objects. How do you create an object? And you've already seen this because you created your calculator brain in your assignment number 1. And you created it by doing this alloc init, nested alloc init. Remember that. So that's always the way we create new objects in the heap. Okay, now creating objects is different from asking some other object to make an object for us. This is objects we're creating ourselves in our code, right? So we always send alloc, which is a method that we inherit from NSObject, and then we always send it some initializer. It might not be init, I-N-I-T, that's NSObject's initializer. We might have a more complicated initializer, but we always send it some initializer, and we always do it nested. Do not separate your Alex on one line and then put your inits on another line, okay? It just leads to bugs. Just don't do it. Don't ever do it. I can't ever think of a case ever where that's been the right thing to do. You might think of one, but don't do it. So like I say, Alec makes space in the heap that's big enough to include all this class's variables. And it sets them all to 0. So if you have any ints in there, they're 0. If you have any object pointers in there, they're nil. Okay? Now, I put a lot of text up here because I want you to be able to go back and refer to this later. But the gist of this line is that every class has to have what's called a designated initializer. This is its focal point initializer. It's the initializer that takes the minimum arguments required to successfully initialize that class. Okay? Now for NSObject, it's init. So if you subclass NSObject, you inherit that as your designated initializer. Right? If you need to put a different designated initializer at your level of inheritance, you need to call your super's designated initializer. All right? So this is not supported by the language. You can't, there's no @ sign something to say this is my designated initializer. You have to do it with documentation. All right? So it's definitely something because of that, because it's documentation only. Sometimes people don't read the documentation. You can get subtle bugs if you subclass some class and you don't call its designated initializer in super. Or if you get confused about what your own designated initializer is, and you have a couple of other initializers that are like convenience initializers, and they're not going through your designated initializer, and then someone subclasses you, and they try to call your designated initializer, but it doesn't work if you call the convenience. You can see how it gets a little messy. So the main thing here, and you can read through this at your leisure, the main thing is that you have to think when you design a class, what's my designated initializer and what's my superclasses. All right, and I'm going to show you why that matters in code in a second here. All init methods, whether it's just init or init with something or other, are typed to return ID. Okay, now this sometimes people say, why would that be? Why isn't NSObject's init typed to return NSObject star? Well, that's because when you start subclassing and then you start calling super init, you're going to have some kind of unfortunate casting going on inside your initializers, because your initializer, you might override NSObject's init and yours wants to return your class star. Well, that's going to conflict with what NSObject is doing. So that's why, just by convention, we make all our initializers typed to return an ID. However, when the callers create your object, or when you call another object to create it, you should statically assign the return type. So see, I have my object star obj equals my object alloc init. Well, my object alloc init returns an ID, but it's going to be assigned to this static thing. So right off the bat, convenience initializer. This is not a new designated initializer. Calculator Brain's designated initializer in this case is still init. Okay? So I've come up with this idea, what if we wanted to have our calculator brain be able to have an array of valid operations? Probably it should be a set, but let's say an array of valid operations. And so we want to have an initializer that says initialize with valid operations. But we're going to define our semantics that if they don't provide any valid operations, then we'll just assume all operations are valid. Okay, so that makes this a convenience initializer. It's not required, this valid operations array. Therefore, we don't want to make it our designated initializer, because then we're forcing people to call this when they could just pass nil. If that's what you want, let them call init, the designated initializer you get from NSObject. But notice in the implementation of a convenience initializer, we call self designated initializer. You see that? Self equals self init. Kind of weird. But init is our designated initializer. Now, we may or may not have an implementation of init, but we certainly inherit one from NSObject because it's NSObject's designated initializer. Right? And then we can use a property or something to set our valid operations to the array. Okay? Now, if that self equals self init had failed and returned nil, would that line self.valid operations equals an array, would that fail? Would that crash or anything? The answer is no. Because remember, if you send a message to nil, it just does nothing. It doesn't crash. It's just like you did nothing. If it has a return value, it would return 0. but it does nothing. And when you say self.validOperations, you're calling the setter of the valid operations property. So you're essentially invoking a method. So if self would nil right there, that line, nothing would happen. Okay, I put that intentionally just to remind you about this property stuff. All right. So yeah, I talked about that. So now here's calculator brain with a designated initializer. Okay, so now I've changed my mind and I've decided valid operations is required. You have to have valid operations, and it has to have at least one valid operation in it, or we are not going to allow you to initialize this class. So now I'm calling self equals super init. Okay, why am I doing that? Because this is my designated initializer. I need to call my super's designated initializer from my designated initializer. Okay, so that's why I'm calling super, because that's NS objects. And then I'm checking the array to make sure it has something in it. And if it does, then I'm going to set my valid operations to an array, and off we go. Otherwise, I'm going to say self equals nil and return self. In other words, I'm going to fail to initialize, because I'm requiring that the valid operation list have at least one operation in it. I should probably go on to check if that operation, that array item is even a valid operation. But in any case, you get the idea here. Notice at the bottom, I was winced to even read this, but you see I have init, I've had to return nil. Okay? Why is that? Because it's not valid to have a calculator brain without a valid operations thing. So if someone calls alloc init on me, I have to return nil, because I'm not in a valid state. All right? So I do all this to emphasize that if you're going to have a requirement in your object that it can't really function until it's been initialized in a certain way, you have to make that a designated initializer. And from there, you have to call your super's designated initializer. The other thing I need to say right there is, this is bad design. All right? You do not want to build objects like this if you can help it. It's much better to build objects that will sensibly default in some way if you send a init or some simpler thing. You don't want to build a bunch of requirements to make your object work. Now, sometimes you can't avoid it. You're going to have an object, it needs some piece of information, or it just doesn't make sense to exist. That's fine. But don't do it willy-nilly. Question?
If you alloc and then init returns nil, what happens to the memory?
That's an extremely good question. Let me see if I can remember how that happens. I think the answer there is, the question is, what happens to the memory that got alloced if you send init and it returns nil? And I think you leak. Having init return nil is really an error condition, right? Your code should never call init here. That would be just a mistake. So probably the right thing to do in init is like raise an exception or something. Have your program crash. It's definitely not, it's an error condition. It's not normal operation. Oh, I didn't init, I'll return nil. Because yeah, you're going to leak that memory. We'll talk about memory leaking in a moment here. All right. Let's talk about another and get it straight. Okay, so that's it for init. So we've talked about allocation, we've talking about init. So now, that's not the only way to get an object. And we've seen this all over the place because we wrote our calculator, we only alloced initted once. All the rest of the time we're throwing objects all over the place, and we didn't alloc init any of them. So there are plenty of classes, hundreds of classes with hundreds of methods each sometimes, that will give you an object. So, for example, ns string new display equals display.text string by appending string digit. You probably recognize something similar to the calculator, right? So there's a couple of objects being given out here. Display.text, that's a string property on UI label that's returning a string. And then we're taking that string and sending it a message string by appending string. That's creating another string, okay, and returning it. So we create two strings there. Also, some of the methods I showed you, like dictionary all keys. That creates an NS array, okay, with all the keys in there. Or string lowercase string returns a new string that's lowercase. They're both immutable. The one you send it to may or may not be, but the one it returns is immutable. The same thing, number with float that we sent to NS number. That returns a new number object. So you can see all kinds of new objects being created all the time. The real question is, who frees all this memory? Who is responsible for freeing the memory that's being allocated for all these objects? Okay, not just these ones above, but all these alloc init things. All right? No garbage collection. Said that before. So on some platforms, the memory is just garbage collected, right? Anything in the heap that doesn't have a pointer to it eventually gets collected, and that memory gets used. We don't have that here, okay? Not on iOS. On the Mac, actually, they do have garbage collection, Objective-C, but not on the iOS platforms. So what is the answer? Reference counting, okay? We're going to reference count these objects, and that's how we're going to know when to free them. So how does that work, reference counting? It's basically a simple set of rules that everyone has to follow, and if everyone follows it, then everyone will be happy. But we all have to work together on this one, okay, inside of our code. All our methods, all our objects have to all kind of agree and do this the same way for this to work. The main rule is that you have to take ownership for an object if you want to keep a pointer to it. All right? So you have an object in your code somewhere. If you want to keep a pointer to that object, you have to take ownership, and we'll talk about how to do that. And multiple owners for an object is okay. You could have 100 owners for an object. Okay? So anyone who wants to keep a pointer to that object has to say they want to own it. Then when you're done with the object, you're saying, okay, I've done everything I want to do. I don't want it anymore. You give up the ownership. Okay? Now, that might seem kind of restrictive, but there's a special magic piece of this, which is that you can actually take temporary ownership of objects. And that's really important for handing objects off to other code, other objects. You need to be able to kind of temporarily own it until they've had a chance to decide whether they want to own it, and if nobody does, then it just goes away. Okay? So that's a key piece of this temporary ownership, and that's what's happening with all the stuff we're doing, calculator, brain, etc. So we'll talk about how that works. When finally no one claims any ownership for an object, okay, everyone said, I don't want to own it anymore, the system will deallocate that object. Okay, its memory will be reused to the heap. If you send a message to an object at that point, it'll crash, okay, because you're pointing to garbage in the heap, basically. All right, so when do you have to take ownership? When do you, this is kind of poorly worded, when do you get ownership, or what makes it so that you get ownership when you say I want ownership? Probably the most straightforward way is anytime you call a method that starts with the letters NEW, ALLOC, or COPY, the convention is the object you get back, you own. Okay? So you recognize one of these very clearly, alloc. When you say calculator brain alloc init, you own that object. Okay? Because you sent it a message that starts with alloc. Same thing, copy. If I made a copy of an object, like a string especially, it's very common to copy those. And then there's a bunch of methods, not a bunch, there's a few methods in iOS where you say new with something and you'll get an object there too. But these are three magic words. When you call a method that starts with one of those magic words, you own the object that comes back to you. Okay? So if you get an object anywhere else, not from calling one of these three things, then you have to send the message retain to that object if you want to own it. And that's pretty much it. Okay? Pretty much, if you call one of these three magic starting word methods, you own the object, or if you send the message retain to an object, you own it. Okay? Yeah?
What if two objects retain each other?
But then no other objects on that.
Yeah, so the question is, what if I have two objects and they're each owning each other and no one else owns anything? Well, as long as they continue to own each other, neither of them will ever get freed. Okay, neither of them ever get deallocated. One or the other of them is going to have to give up their ownership of the other one, right, for it to go away. And you're probably worried in your mind a little bit about circular references. So that turns out that's not going to matter. Okay, because we're just talking about ownership here, and anybody can own an object. And if you own, you wouldn't express ownership and keep ownership of an object unless you wanted to do something with that object. So you'll see that it works out in that sense. All right, so what about all the rest of the ways you get an object? So if you don't call new or alloc or copy, you call some other object, you have to say retain if you want to keep it. How does that work? And because how is someone going to give you an object that they're going to give you the opportunity to retain and own, but they don't own it anymore? Because they don't want to own it until after they only want to own it long enough to give you a chance to own it yourself, and then they're done with it. They created it for you probably, right? And make something for you. I want to give it to you. How do I return that from a method? Well, the answer is there's a way to do this temporary ownership. And the only reason you would temporarily own an object is because you want to give it to someone else. And you want to give them a chance to retain it before it gets deallocated. Okay? The other way you can do it is you can return an object from yourself that you own, and you're not going to get deallocated until a while down the road, long enough for the person you're giving it to. This happens with instance variables. You give out one of your instance variables, presumably the person who called the property or the method in your object to get that instance variable, you're going to live long enough that they're going to say they want to retain it before you get deallocated. Okay? But mostly we do it with this temporary ownership. So we'll talk about temporary ownership in a second. So how do you give up ownership when you're done? So you have an object, you own it, either because of the magic 3 words or because you said retain. How do you give it up? Well, you send this message release. Release says, I don't want to own this object anymore. Now, you have to be careful. If you say, here's an object, I'm retaining it, if you say release twice, that's bad. Because these releases are not kept track of between all the objects. It's a reference counting algorithm, right? So if you release it twice, you're releasing your own ownership and you're releasing someone else's as well. Some random persons you don't know, not a particular object, but you're lowering the reference count by 2. So don't do that. All your retains and releases, all your takes of ownership have to be matched with releases of ownership. Okay? And this is the number one kind of hard to find bug in your program is you're releasing an object twice or you're not retaining it in the first place. Okay? Those are going to be your 2 big memory allocation bugaboos, things you're going to have trouble finding, is that. So you always have to match them. Now that might sound like a huge burden, but it turns out not to be that hard because releases happen mostly in the same place in your code. And we'll show you what that is. So let's go back to the temporary ownership. How do we do this temporary ownership thing? There's a special method in this object called auto-release. And what auto-release means is I'm releasing this object. I don't want to own it anymore, but not quite yet. Okay, wait until the call stack unwinds, basically. Or to be more accurate, it's wait until the event loop finishes processing this event. Okay, at the very end, presumably everybody involved who wanted to take ownership of that object has a chance to retain it, and if no one does, boom, it gets released. Okay? So that's how we do this magic temporary ownership. We just send auto-release to an object. So I'm going to give you a couple examples here of how I would create an object to give it away using this auto-release. So here's show me the money. This is a method, and it returns a pointer to an object, money star. Again, not something that's in the SDK, just something I made up. It takes a double, which is a certain amount of money, and presumably makes that an object that's worth that amount of money and returns it. So what does the code look like to do this so that memory management works? All right, so first I'm going to create the money. Okay, money equals money alloc init with that amount. All right, so I've asked the money class to create one, to allocate some space for it, and to initialize it. Now, after this line of code, we own the money, right? Because we called alloc. Alloc is one of the 3 special words. So we own it. Now we're responsible for releasing it. If we don't release it, this memory will leak. It will never get freed out of the heap, ever. Okay? So we have to release this thing. Well, on the very next line of the code, I say, return the money. Now I don't even have a pointer to the money anymore. I can't release it. So I can't execute my responsibility. You see the problem? Okay? So how do we overcome this problem? Well, the answer is, we use this auto-release. Before I return it, I say the money auto-release. I've now satisfied my responsibility to release this object, but it hasn't quite happened yet, because if it happened right now, the object would deallocate, and I'd be returning a deallocated object, right? A bad pointer. So that's no good. So by putting auto-release in there, it's going to wait to do the actual deallocation of the memory until later. But meanwhile, I've satisfied my requirement to release this object. Now, the caller, whoever's calling this, they say money star my money equals bank object. Maybe this is a bank object implementing this. Show me the money. Give them the amount of money. And then they say my money retain. Okay? And that my money retain makes it so that the caller owns my money, right, before it gets auto-released later. So when the auto-release happens a while later, it won't release because someone still owns it, namely the caller. Everyone make sense? Okay, so this is not the only way, though, to create an object and give it away. Okay, allocating and knitting it and then calling auto-release is not the only way. So here's another example. Here I've created an array of cool cats. Here I've done the alloc and knit, and I've returned it. This is bad. We saw on the previous slide. I'm going to make the same fix. I put auto-release. Woohoo, I'm good. But there's a better way to do this than this. Okay, in fact, I'm going to show you two better ways to do it. All right, one is instead of up there where I say NS mutable array, alloc, and knit, what if I asked mutable array to give me an auto-released mutable array to start with? Okay, and I can do that by changing that line of code to say NS mutable array. So array is a method a class method in NS mutable array. It doesn't start with alloc or copy or new, so I don't own the object that comes back. So it must be in this magic auto-release state, right? So if it's in that state, I don't need this return value auto-release down here. In fact, I got to get rid of it because otherwise it would release it twice at the end of the automatic releasing period, okay? So this makes the code a little simpler, right? Because I start out with an auto-released object that I got from NS mutable array, and I add the objects I want to it, and then I return it. And this is perfectly fine. But there's an even better way to do this. And this comes into this whole thing of mutable arrays versus immutable arrays, and why is one more common than the other? And that's that there's a method in array that just lets me life is 42, meaning a percent at sign is %d. So that string with format method, that doesn't start with alloc or new or copy. So it returns something that's auto-released. If I wanted to keep that string, I would have to send retain to it if I called this. Same thing with dictionary with objects, array with contents of file even. Okay, it's possible to write arrays out to disk and read them back in. And when you do, the array you get back is auto-released. Okay, if you want to keep it, you retain it. If you don't retain it, it just goes away. All right? So you're going to see this all over the place, this auto-release mechanism. It's actually very few times when you have to call retain and release, because most things are being auto-released. You might be thinking from this previous slide, well, what about those strings that I put in that array? Who owns those? Okay, and that's a very good question. Who does own those? And the answer is when you put anything in an array or a dictionary or a set, they take ownership until you remove it. Then they release ownership if it's mutable and you release it. Does that make sense? So that's important to understand. And a lot of times you'll put stuff in there and return it, and if someone else wants to take it out because it's mutable, that's their responsibility to retain it when they get it out. Okay? But when they get it out, they'll have a chance to retain. By the way, yeah, question.
So if you release an array with stuff in it, will it then also call release on all the objects that it contains?
Yes, the question is, if I have an array with a bunch of objects in it, and I release the array, I say ns, the array variable release. Will it release all the items inside? And the answer is yes, it will. Okay. So this @ string is kind of weird. You can kind of think of them as auto-released, but really the answer is they never get released. They're constant. Okay? So you can make a lot of mistakes with @ strings because you can release it all you want, you can retain it all you want, you're not going to leak, and you're never going to get a bad pointer. They're constant strings, this @ quote. But you can kind of code, when you're coding, think of them as auto-released, kind of. The other thing about strings, we don't usually retain strings. Okay, we copy them. This is the only class really where I think we routinely say copy rather than retain. And the reason we do that is because when we copy a string, we get an immutable version of it, even if the thing we copied was mutable. Okay, and a lot of times if someone's handing us a string as an argument, they might have built it up using NS mutable string, and they hand it to us, but we don't want to be having a pointer to something that we can, muck around in, right? We don't want it to be mutable for us, unless our API says mutable string. We just want to get a string that's nice and safe and read-only, and so we send copy. And a string very efficient at doing copy. Okay, so don't feel like, oh, I'm copying this whole string, it's killing me. It's very, very efficient. If it's already immutable, it's just basically like a reference count. It's kind of like retain. If it's mutable, it's going to copy the bits out of there. but in a very efficient way. So string objects we usually copy, not retain. Any place you would think about retaining a string, you probably want to copy it, actually. One kind of programming technique, you want to release objects as soon as you can. Don't have an object sitting around, you have ownership of it, but you're really never going to do anything with it again. You're just too lazy to release, or you promise you're going to release it some other time. Release it right away. Okay? The reason for that is people reading your code will know that you're not going to intend to go use that object later. Okay? So release them as soon as you know you don't want them anymore. It's not an efficiency thing, it's just more of a code readability thing. Okay, deallocation. So what happens exactly when the last owner calls release? Nobody owns this object anymore. A special method in NSObject called dealloc gets called. All right, and in addition to that, the object's memory is returned to the heap, okay, to be reused, obviously. Okay. After this, if you call a method in that object, it will crash your program. Okay. So let's talk about dealloc. You should override dealloc in your class, but never call dealloc. You don't ever call dealloc. Okay. Dealloc is called for you when the last owner releases. You never call dealloc. Every quarter, it seems like people get this a little confused, and they say, oh, I'm done with this object, I'm going to call dealloc to deallocate it. No, never, okay? You call release, and when the last owner has released, now it will deallocate it. What you do in your dealloc, by the way, when you subclass it, is you release your instance variables. You don't dealloc them, you release them. You call release on all your instance variable objects. Okay? That's what you do in your dealloc. Because if your dealloc is being called on you, you're done. Your heap is going to get, your space in the heap is going to get eliminated. So you got to clean up everything, and there's nothing you can do to stop it at that point. You're already headed towards deallocation. You cannot stop it. So in your dealloc, you want to clean up all the memory usage you're doing. So most of your alloc inits in your code, the releases, since alloc init is like doing a retain, right? It's alloc, so you own it. Your releases corresponding to that are going to be in your dealloc, because you're going to be alloc and initting instance variables mostly, like the calculator brain, which is a brain, right? That was instance variable in our controller. We did not put release for our brain in our dealloc, and we needed to. Okay? So in your assignment today, one of the required tasks is go back to the calculator thing we did last week and fix the memory allocation problems, and that's the one you're going to want to fix. Okay, you're going to want to release that brain in your dealloc. Okay? I say you can never call dealloc. Actually, there is one place you call dealloc, which is in your dealloc, you got to call super dealloc. Because obviously you want to give your super class a chance to release its instance variables too. Right? So that's the only time you ever call dealloc. Inside your dealloc, you call super dealloc. That's it. So here's an example of a dealloc. Maybe it's my controller, I've enhanced it some, I'm releasing my brain, I've got other object instance variable, I'm releasing that, and then I'm calling super dealloc. Simple. Okay, this is what your deallocs always look like. Just release your instance variables, super dealloc. And some people say, well, I should set my brain to nil now or something, because I just released it. It doesn't matter. This object's never going to see the light of day. Okay, it's going to be dealloced. So you don't have to do anything except for do your releases. Okay, @sign properties. There's some special memory allocation consideration with @sign properties, right? Because you have to understand who owns an object that's returned from a getter that you pass in as an argument to a setter. Okay, you want to be a little bit careful about who owns this here. So getter methods usually return instance variables directly. Not always, especially read-only getter methods sometimes calculate something they're going to return, but sometimes you have things where they're returning things directly. When you do that, usually you're not going to retain them an extra time and auto-release them. Usually. Sometimes you might, though. Usually you're just going to return it, and the person who's calling it is going to count on the fact that they're not going to deallocate you, they're not going to release you until they've made a decision to retain your instance variable through the property. So usually the getters, you just don't do anything special. You just return whatever you want to return. However, if you have a property which is a special property, like it's calculated somehow on the fly, or you're giving it away but you don't want anyone to modify it, that's a common thing, right? You want to give away like a copy of your instance variable. Does that make sense? You want to give away that data, but you don't want them to be able to mess up the internal state of your object. Then you might retain or copy the object and then auto-release it and then return it. Okay? And you're going to have to do that in your assignment today. So here's an example of this assigned property thing. So display is a UI label, remember from our calculator, and we're using its property text, which is a read-write NS string, okay? And we are using it here. I'm just going to go through what happens here so you understand where the ownership of this property happens. So first, inside my square bracket there, I call display.text, and I get the text string back. Okay, when I got this back, if I wanted to keep it, I'd have to send it retain. Okay, but I'm not going to keep it. All I'm going to do is pass it to this other, I'm going to use it rather, to call this other method, string by appending string, and get myself a new string back. So I never kept the return of display.text. I never kept it. I only used it briefly. I don't have to, since I didn't take ownership of it, I don't have to release it. Same thing here. This string by appending string, it doesn't start with alloc or new or copy, so I don't own that either. And I'm not going to keep it either. I'm going to go use display.text, which is the setter for the text property in UI label, right? I'm going to use that to set the string. So I never owned any of these strings, and then didn't need to, because I was only using them temporarily, right? So that's a very common usage with these properties. But what about, so that's property getter method. What about the property setter methods? When you set an object, via property, does the object that you set it on, do they take ownership of it? Right? Generally, they probably want to. Why else would they be having you set this thing on them if they weren't going to own it? All right. So unfortunately, though, and so if in your implementation of a setter, you would want to say retain on the argument of the thing that was handed to you to set in your object. But what about @synthesize? Because it makes that setter for you. How do you make it retain? Okay, it's not done automatically. Instead, you have to use this notation: @property parentheses retain NS array star my array. So this is a property. It's an array. Okay, and the setter that synthesize makes is going to retain that thing. Okay. The second line, copy, same thing, except for it's going to copy it. That would normally use with a string, NS string star. And then the third one is assign. That's when it's not going to retain or copy it. And there is one really important place that we do this in iOS, which is when we set the delegate of a view to be its controller. Okay? I talked about delegates, all the will, should, did. Do you remember that? Well, when you do that, the view doesn't really want to retain its controller because its controller owns the view. Remember, the view is like the controller's minions. So the controller generally creates the view and owns it, and the controller is going to live longer than the view at all times. The view is always going to live shorter time because the controller owns it. It's its minion. So there is not the retained back pointer there from the view of the controller. That's all I'm going to say about today because I'm running out of time and I need to show you this demo. So here's an example of what @synthesize will create if you use retain. Notice that it will release the previous value of the instance variable before it retains the new one. You see that? Also notice that the retain method returns the object you sent it to. So you can do this name equals a string retain. You don't have to say a string retain and then name equals a string. Same thing with auto release. You can return that directly. Here's copy, exactly the same. Notice it releases it because copy is one of the 3 magic words. So when I said copy of it, I took an ownership. I have to release the old version. Everyone understand why we're releasing the old version? This setter could be called multiple times. I got to keep releasing the previous one I retained or copied so I can set the new one. And then here's the one with assign. There's no copying or retaining going on, so there's no releasing going on either. This is the default, unfortunately. Maybe fortunately. All right, so next time I'm going to talk about view hierarchy and custom views, the application lifecycle, the view controllers lifecycle, navigation controllers. We're really going to start getting to the heart of how you build a significant application next time. But right now I'm going to do a demo. Got 10 minutes to do it. It's going to be tight, but we'll see. The demo is called Collector. I'm going to post full code, even though in 10 minutes I'm only going to get part of this code done. I'll post the full code. I already have, actually, or maybe not. But right after the lecture, I'll post the full code for this thing. What it does is really simple. It collects objects, strings and numbers, and then reports statistics about them. How many numbers it collected, how many strings it collected, etc. This is obviously contrived to show you how to do introspection and arrays and dictionaries, etc. So in this demo, our model is this class called Collector that I'm going to create. The view is just going to be a bunch of random buttons that have strings and numbers on them, and when you click on one, it's going to collect it. And our controller is going to be Collector View Controller, and all it's going to do is get the messages from the buttons and turn around and call the model to collect. As I do this, watch for how we use NSNumber to wrap primitives, how we use introspection, and how I do properties. Okay? And also enumeration and some other things if I get to that. So that's the demo I'm going to do. So I'm going to start from scratch here in Xcode. And I'm just going to create a new project. I'm going to call it, Collector. Collector. So it's the same as when we did our calculator. You can see here we've got our view controller right there. And we've also got our view, which is our calculator view controller. I'm going to start off right away by creating my model, which I'm going to call Collector. Collector. All right, and so actually I'm going to move Collector up to my classes here. So let's talk about the API for our Collector class. It's going to basically have one important method. Let me make this window bigger, sorry. Okay. So it's going to have one important method, which is called collect. Okay? And collect is going to take an ID, any random object, and it's going to collect statistics about the objects that it collects. So you just call collect on it a whole bunch of times with strings or numbers. It could be enhanced to do other things over time, but that's the two it's going to do. And then it reports statistics. So the two statistics I'm going to do here, I'm making them properties. One is total string count, and the other statistic is total number count. Oops. Okay, now the way I'm going to implement my collector is I'm going to have a mutable dictionary called counts. And what counts is going to do is it's just going to count every time an object of any kind comes in. So if the same object comes in 5 times, this dictionary's value with that object as the key is going to be 5. Okay, so the values in this dictionary are NS numbers, and the keys are either NS strings or NS numbers. Okay, make sense? Really simple, somewhat contrived, but I want to be able to show you how to do dictionaries and stuff. So let's write collect first. So void collect ID and object. And collect is really straightforward. It's just going to say if an object is a string, or if an object is a number, because that's the only two things I'm going to handle in this class. Again, it could be enhanced over time. Then I'm just going to find out how many of this object I already have and just add 1 to it. So I'm going to say NS number existing count equals self.counts. Okay, I'm going to have a private property for my counts. Object for key, this object. So I'm just going to say for this object, what's my existing count? And then I'm just going to say update the counts. Counts set object, NS number with int existing count int value plus 1 for key and object. Hopefully I got all my square brackets right there. And that's it. So that's all collect is going to do. But I do need a private thing here for my count. So I'm going to say interface collector @ property, ns mutable string, dictionary star counts, and then I'm going to @ synthesize counts. Actually, no, I'm not. I'm going to lazily instantiate that, so I'm going to go ns mutable dictionary star counts, if not counts, counts equals ns mutable dictionary alloc init, and then return counts. Now, okay, anytime you type alloc or new or copy, you immediately want to think, where am I going to release this? Okay, always. That's always what you want to think. So I'm thinking, where am I going to release this? Well, this is an instance variable, so I'm going to release it in my dealloc. Okay, I'm just going to say counts release super dealloc. Okay, so now I'm safe. I've alloc something, but I've released it. I'm good. All right. So let's collect. Let's do total string count here. Total string count. Pretty straightforward here. I'm just going to collect the total number of strings by doing this. Enumeration. So key in self.counts. All right. So I'm just going through enumerating through my keys. I'm going to say if this key is kind of class a string, then total plus equals the value for this key. Self.counts object for key int value. Okay, because that's how we're keeping track of how many of that object there are in there. And then I'm going to return total. Okay, numbers is I'm going to, for speed here, I'm just going to copy and paste. You probably want to factor this code out would be better, but I'm going to just change it. Total number count. Change this to ns number, like that. Oops. Okay. So that's that. Let's see. This is problem here. This is read only. Oops. Read only. Okay. All right. So that's it. That's my model. I'm completely finished with my model. The next thing I'm going to go do is do the view controller interface, not the implementation of it, but the interface of it. The only thing my view controller has is it has the model, so collector star. I'm going to call it model, actually. Could call it collector, maybe, but and I better import collector.h. And then it's going to have a couple of outlets. I'm going to show this total string count and the total number count in some text fields. So I'm going to have IB outlet, UI label, star total strings, and IB outlet UI label star total numbers. Okay. I only have one target action here, which is collect. It's going to take a button as its sender, similar to our calculator. I'm just going to get the sender. I'm going to ask if it has a number on it. If it has a number, I'm going to put a number in the collector. If it has a string on it, I put a string in the collector. Let's do our UI really quick here. The UI is very simple. I'm just going to have a label here, which is strings. We'll make that a little bigger. We can. There, right there. We'll make the alignment there. So this is just a label here. Copy and paste. Strings and numbers. And then we'll make another couple labels to actually show the values. Start them out 0. Paste like that. Let's wire these up. So I'm holding down Control and dragging out. This is total strings. Control, drag this out. This is total numbers. Then I'll just get a button, bring it out here. This is going to be my prototype for sending collect. So I'm going to wire that up to collect. And then I'm just going to copy and paste this a whole bunch of times. Paste, 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 paste. Oops. I'll make a really nice UI here, well lined up. Okay. And we'll put some words in here, maybe red. How about cat? How about some numbers, 7 and 35.4? And how about like hello? And maybe goodbye, and up and down. Okay, so remember I copied and pasted them, so they're all pointing, they're all going to say collect. So that's the end of that. We go back here, we'll do our implementation of our controller. I'm going to get rid of all the junk in here, except for I'm going to keep dealloc this time, and I am going to dealloc my model. Release. Okay. So now let's do the collect. IB action, collect, UI button star sender. Here's what I'm going to do here. I'm going to say, I'm going to get its double value. I'm going to say double value equals the sender's title labels texts double value. And I'm just going to say if the double value is non-zero, I'm going to assume it's a number. So if I had a 0 on a button, that wouldn't work, but whatever. So if it is a double value, then I'm going to say to my model, I'm going to, for expediency, do this here. So I'm going to say to my model, collect an NS number with double value. Oops. Otherwise, I'm going to have my model just collect the sender's title, sender's title label text. Okay? And then I'm going to actually put, just for speed here, if my model is not created, then my model equals collector alloc init. And again, I released it here in dealloc, so that's good. The last thing I want to do here is update my UI every time they press a button here. So I'm going to create a little private method, update UI, and it's just going to say total numbers, total numbers dot text equals not this thing, NS string with format, %G, it's actually %D, and then I'm going to guess my model, total number count, there you go, and total strings dot text equals NS string with format, %D, model dot total. Now this is probably not that good because if my update UI got called before my collect, then this would crash, or it wouldn't crash, but it would print 0, which maybe that's okay actually. Maybe that's not even a bad way to have this work because my model is only created right here. So anyway, I think this should work. This is speed programming. We'll find out here. So now, see, as I press on numbers, it tells me more and more and more numbers. If I press on a word, so you can see it's collecting the statistics on what's pressed, okay? Now, a couple of things let me tell you about. One is the code that's posted online. I did a couple more things, like I actually create a set of all strings that were ever added, okay? And since a set only has each string in there once, then it's possible to find out how many unique strings or how many unique numbers as well. So take a look at that because you will have to do a set on your homework as well. I'm going to take, I know I'm over time here, but I'm going to take 1 minute to talk about your homework, just so you have a feeling for what that's about. It'll be posted right after this lecture. Your homework is basically going to be to take your existing calculator and modify it so that it works with variables. So that instead of just saying 3 plus 4 equals, I can say 3 plus x equals. Okay? And it's going to remember an expression with, could be multiple variables. And then you're going to have like a test button on your UI that just says solve, and it's going to kind of pick random numbers for your variables just for it to solve it and see if it's doing the right thing. So this homework is primarily about how to do introspection. You're going to need a mutable array in there for sure. You're going to want to understand a little bit about how to build an API in Objective-C. I actually show you a new API for your calculator brain. And this homework is really about your calculator brain. All you're doing in the UI and the controller is mostly just putting the buttons so that people can press on variables, and then also that little solve testing button. So this is really about building a calculator brain that has a more sophisticated API. Okay? And I don't walk you through the whole thing like we did last week where I'm showing you every single button to click. However, I am going to mostly walk you through this one how we're going to kind of do this, how we're going to implement this, etc. So I'm not really quite expecting you to be able to just automatically go out and build something sophisticated in Objective-C, but I still want you to get the feel for what it's like to use all these various classes and such like that. So it seems like a long homework, but it's actually not a lot of code to write. There's a lot of explanation in the homework as well. If you have any questions, you know where to find us. And sorry for keeping you late, and I will see you next week.
For more, please visit us at stanford.edu.